Hello students, welcome back to classes on computer organization. Today let us discuss about the memory hierarchy. So this is the third module concept. Let's see the types of memory. Basically we have a primary memory, secondary memory and cache. So what is primary memory? Primary memory is a random access memory, right? Random access memory, RAM we call it as. And secondary memory is the hard disk, or you can say it only memory. So the processor, here you can see the hierarchy where you can it involves the processor components. Along with processor we have primary and secondary memory as well as cache. Okay, what is cache memory then? Question comes. So cache memory is a small amount of memory which acts as a buffer or intermediate. So what is the use of this intermediate? Question comes, right? See, this intermediate, the use of this intermediate is to boost up the computation or speed up the computation. You might ask how the computation speed will be increased. See, whenever you want to execute a program, the program should be brought onto the primary memory. Okay, please remember, the program should be brought onto it should be there on RAM or primary memory, which whenever you access a data or whenever you execute a program, it will map from secondary to primary. Okay, so while mapping, so what will happen? The part of the file may be resided in the secondary storage, so amount of time needed to bring that data from secondary to primary counts, isn't it? That affects on performance. To speed up the performance, what we can do is we can fix a buffer in between. So it is something like suppose you are sitting in a classroom, say classroom number 17 you are sitting, okay, and there is a water filter which is fixed just outside your classroom, that is 17, okay, and obviously there is a water filter which is fixed in the ground floor, you are aware of it, and you are on second floor. See, so where you will go if you need water? Okay, suppose in between there the session is going on, so you feel thirsty, say, and you need water, so where you will go? Obviously you will look into where the water filter which is fixed just outside your classroom, isn't it? So if the water is not available in that filter, then what you will do? You will search for the alternate filter, that is the main filter which is fixed at entrance, say at ground floor. Getting no? So the concept of it is very easy concept, very simple to understand. The concept of cache exactly works on the same principle. So what is that principle? It is associated with, it is closer to primary memory. Actually the cache memory module which is closer to the primary memory, okay, and this primary memory recently stored data. As per the principles of cache, the recently stored data, small amount of data which will be resided on the cache. Why only the recently stored data? Recently stored data because it is the probability that recently accessed data will be required in near future. That is what the general principle of data accessing. So because of that, the recently accessed data will be resided on the cache. So if the data is available on cache, which is, since cache is closer to primary memory can directly access, if the same data is required in future, means it can directly have an access from the cache. No need to go to the secondary storage. That is what, if the water is available at the filter, okay, if the water is available at filter which is fixed just outside your classroom, then you don't have to go to first floor, right? Ground floor. Getting no? You can see the diagram here. Processor which involves various processor registers which we have discussed earlier in the previous modules. Then it has got a primary cache and secondary cache, L1 and L2 cache. They are called as level 1 and level 2 cache. Okay, just recall the L1 and L2 cache from the first module, right, which is called as primary cache and secondary cache. Then we have a primary memory and secondary storage or magnetic disk. Just follow the arrow mark. So increasing size, if you compare the size of primary cache, it is smaller than secondary cache. So as you proceed in the hierarchy below, size increases, right? As size increases, speed reduces. Please remember, as size increases, speed reduces. So size and speed, they are inversely proportional to each other. Okay, you can check the arrow mark, you will come to know. And as size increases, speed reduces, as well as cost also reduces. Cost per bit, which is less in case of secondary storage compared to primary memory, as well as compared to cache. So even though for a small amount of cache you need to spend a lot compared to secondary storage. Okay, secondary storage, it is very easy to understand. We just analyze the cost of RAM as well as cost of secondary storage. You can take the example of your pen drive or secondary hard disk, magnetic disk, right, which will be available at cheaper prices, you are aware of, right, compared to RAM. So this is one of the important topic from this module. Next we will be discussing about the cache memory. So here is the cache memory, as I told you earlier. Cache which is the intermediate between processor and primary memory. So primary memory, if a processor or needs any data, so it, instead of looking into the primary memory, what it will do, it will simply access it from cache to boost up the performance or to speed up the performance. So it works on the principle saying temporal locality or spatial locality. So what is temporal locality? The recently executed instructions are likely to be executed again very soon. That's why cache which stores the data, recently stored data, and spatial, the instructions in close proximity to recently executed instructions are also likely to be executed. This is what spatial. So cache works based on both the principle, temporal and spatial. Temporal is the one, the recently executed data or instruction to be called again in very soon, in near future, and spatial means associated or relevant data or instruction, you can say. Okay, there is a probability of calling the relevant instruction in near future. That's it. Then another important topic with respect to cache is so write through and write back protocol. So read and write of two types of operations. Since it's a memory, we can perform two types of operations on it. One is read operation and other one is the write operation. So write operation in the sense, for the first time, if the data is not available on cache, then data will be referred from primary memory, as you are aware of. If the data is not available on cache, you have to look into, as per this diagram, say processor will look into cache, and cache will be, if there is a data in cache, then obviously data will be given to processor from cache only. Otherwise you have to look into, processor should look into primary memory or main memory, right? So processor, what it does, so it will look into cache, say the data is not available. So if the data is not available, what will happen? It will look into the primary memory. Since it will be the recently executed data, now you have to follow the principle of cache. All the recently executed data should be placed on cache. That's why you have to perform the write operation on cache now, right? Automatically it will be performed actually. So there are two principles we have. One is write through and other one is write back. So write through is the one whenever the data is accessed from primary memory, so data is parallelly copied onto the cache and hence onto the processor register. right? That which is called as write through, and write back is the one. Primary memory will send the data to processor via cache, and data will not be initially stored on cache, and after certain interval data will be copied onto the cache. That is what write back procedure is. Okay. So another important topic here is mapping function. What is mapping? So mapping, actually I have asked these questions, I have given this as an assignment actually, right? Just go through. So mapping in the sense, since the size of cache is small compared to primary memory, right? So the amount of data or entire amount of primary memory cannot be placed onto the cache at a time. Only the certain amount of data from primary memory can be placed, right? So placing the data, copying the data, or placing the data from primary memory onto the cache is called as mapping. Okay. Why mapping is required? Question comes. Mapping is required because you cannot copy the entire amount of primary memory onto the cache at a time due to size limitation. Size of RAM or primary memory is usually in terms of GB, whereas size of cache is in terms of MB. Please try to understand. Only certain amount of data can be placed at any interval. Once the cache is full, you should go for replacement algorithm. Replacement in the sense what? You have to delete certain amount of data from cache and you have to fill up it with the new data, right? That is what replacement. So mapping function, there are three types of mapping we have: direct mapping, associative mapping, and set associative mapping. Okay. I'll begin with the mapping function, direct mapping, in the next session. Okay, in the next video I'll explain about direct mapping. Next will be associative, and finally set associative. Please try to understand. This is one of the very important topic from this module. Okay, if you study mapping function, straight away 10 marks question you can, 10 plus marks question you can expect in the final exam.